Hello everyone, welcome to AriserTalent. I am your maths faculty Arpita Sharma. Students, we are right now studying coordinate geometry, right? Okay, so starting with the name of this chapter, that is coordinate geometry. Now students, I have taught you about the coordinate geometry and the distance formula and the basic concept of that. We have covered in previous lecture some questions, some numerical based on distance formula. Okay. So now moving for the next question based on the same distance formula. We are having here prove that the points -3 and 0 and 1, -3 and 4, 1 are the vertices of an isosceles right angle triangle. Find the area of this triangle. What's saying? It has given us 3 coordinates, the abscissas and the ordinates. Okay, so this is one point, this is second point, and this, let's suppose, third point. So can we name it like P, Q and R? Okay, let it be P, Q and R. Right, now it's saying that you have to prove that this is first isosceles triangle first, then second right angle triangle. So these two words are of importance here, that isosceles triangle and right angle triangle. So both the conditions should be satisfied. Now what is isosceles triangle? In that, if this is a isosceles triangle, any two of the side will be equal to each other. Either this and this will be equal, or maybe this is equals to this, or maybe this one, this equals to this. Okay, so this equals to this. So there are 3 patterns. So any of two sides may be equal to each other. Okay, so we have to prove this first thing. Now the second thing that this is a right angle. Now clearly the hypotenuse is what? This the largest side. So to beat an isosceles plus a right angle, what it should be? That these two sides should be equal. Why not these two? Because if hypotenuse is equal to any other base or height, it cannot be possible. It cannot be possible because this is the largest side. Largest side cannot be equal to any other side of a triangle. Okay, got my point? Okay, so we are having these two lengths equal and this is our hypotenuse. That will be the thing. Now the square of this side and the square of this side and the summation of 2 will be equals to this square, the side square, by the Pythagoras theorem. Okay, right. So now what? Now we have to solve this question. So what we'll start with? We'll start with the given parameters. We always do like that. Okay, so the given is, let's suppose a point P which is -3 and 0 given, and the Q is given 3 and -1, not -1, okay, 1 and -3, okay, and the third point, let's suppose R is given 4, 1. Now what we have to prove? What we have to prove? That PQR is right angled, it's okay, first thing, and isosceles triangle. First thing right angle, second thing isosceles. Now the solution part. What will we use? We will use the distance formula. We all know the distance formula, students, don't we? Say yes or no. Yes. Okay, so distance formula is distance equals to root of difference of abscissa square plus difference of what? Ordinate square. This is the formula, right or wrong? Right. So we'll be working with this formula now. If I go with this AB, not AB but PQ. Okay, so if I talk about PQ, difference of abscissa. Now this is abscissa and this is abscissa. So difference root, that will be -3 -1 square plus difference of ordinates 0 minus of -3. -3 is +3. Okay. Now I'll solve it here. That will be 3 and 4. -4 square 16 plus 9. 16 plus 9 is 25. Root 25 is 5. Now this is 1. For the second, I'll be taking QR. If I'm having 3 points P, Q and R, what sides can be drawn from these 3 points? What enclosed figure will it be? PQ, QR and PR. Nothing more than that, much than that can be possible. The fourth combination cannot be there. Okay, so QR, first PQ, then QR, and we'll talk about PR then. Okay, so if I talk about QR, now Q is here and R is here, so 1 -4 square plus -3 -1 square. Again 3. This is -3 square is what? 9 plus this is 4 square is again 16. So that will be again 5. Now what does that mean? This is 5 and this is 5. Okay, 3 here and 4 here. So this is 5 and this is 5. So two sides, that is PQ and QR. Now Q is common, na? So we are having PQ here and QR here. Why? Because I have told you that hypotenuse, the side hypotenuse will be the unequal one, because this hypotenuse cannot be equal to any of them because it's largest. So that will be 5 here and that will be 5 here. Okay. Now it is proven that it is isosceles. Isosceles is proven till there. Now what about right angle triangle? We have to find out PR and look whether the PR square is equals to QR square plus PR square or not. Okay. So PR. Now PR is what? Here if I go with that will be -3 -4. Okay, square plus 0 from here minus of 1 square. Now that will become 4 and 3, that is -7 square 49. Here 1 square, so root 50. Now if I talk about root 50, so 50 factors will be 2 multiplied by 5 multiply by 2 multiply by, that will be 10 and that will be 10 multiplied by 2, sorry, that will be 5 multiplied by 2 multiplied by 5. So that is 10 and that is 50. So 5 will come here and root 2 will go there. So that will be, the root 50 will be what? 5 root 2. Okay, so that will be 5 root 2. Okay. So now draw this diagram. If this is true, then this is P and this is Q and this is R. Okay. If that's true, which is given in question, so that PQ is, we have 5, we have it 5 here, we have it 5 here. So by the Pythagoras theorem, this PR square should be PQ square plus QR square. That should be done. If it's a right angle triangle, the hypotenuse square will be equals to perpendicular square plus base square. This is the Pythagoras theorem, we know. Okay. Now we are having these three values. If triangle PQR is right angle, right? Okay, if this is so, then this PR square will be equals to PQ square plus QR square. Okay, so come this side. Which side you have to come? Okay, I'll be rubbing this portion. So from the figure, you know this has to be done. Now PR square, if I talk about PR square, PR square's value is what? 5 root 2. So that should be, PR square should be equals to PQ square. PQ square value is 5 plus 5 again, because it's 5 and it's 5 also. So that will be 25 plus 25 equals to 50. PR square. That implies PR equals to root 50 and it's equals to 2 root 5. Right. This is 2 root 5 here. Okay. By the Pythagoras theorem. And if I calculate, this is 5 root 2 here. Sorry, is this 2 root 5? No, it's also root 50. So that will be 5 root 2 also. Okay. So this is 5 root 2 here and this is also 5 root 2 here. Okay. So now if I name it like equation 1, 2, 3 and 4. So student, by equation 1 and 2, by equation 1 and 2, isoscale, two sides are equal. Triangle is isoscale. First thing. Second, by equation 3rd and 4th, by the equation, this 3rd equation and this 4th equation, triangle is right angle. What? Right angle. So isoscale and right angle, hence proved. Proved. Now note this, students, so that we can move forward. Okay, noted? Noted it completely? Okay. Should I rub this? Right. So what we applied? We applied a little knowledge of triangle. Now, if your concepts about triangle is not clear as that much, you can just pause this video and go to the section triangle, chapter triangle, and visit there. Okay. These concepts are all mentioned in very detail that side. Okay. These are very small concepts. So, I know you guys know that. But in case if you don't know, then you may visit. Okay. Okay. Next, find the coordinates of the center of the circle. Find the coordinates of the center of the circle passing through the points 0, 0, minus 2, 1 and minus 3, 2. Also find its radius. Now, what it's saying, that you are having coordinates of the center of, you have to find the coordinates of the center of the circle passing through the points. Passing through the points. So, there are 3 points. Understand this. If I talk about this axis, here is 0, 0. Now, minus 2, x minus 2 and 1 here. So that will be something like there, and minus 3, 2. Now minus 3, 2, minus 3, 1, 2, 3, minus 3 and 2. So that point will be here. So that's what, that's a circle. We're having a circle here, right? It's looking like a circle or not? No? Okay. We should again make a beautiful circle. Okay. So let's suppose now this is a circle. Now what it's saying that it's having a center. It will obviously have a center. Now the coordinates, the abscissa and the ordinate is not known. Now something which is not known, will write that x and y. Okay, so I'm writing here x and y simply. Now it's having some point. Now it's having some point, but he's not naming them. So okay, we'll do that for him or her. P, Q. It's my favorite, P, Q, R. So you should write it too, P, Q, R. Okay, it's like good at, you know, speaking. P, Q, R. Okay, so the first P is 0, 0. So now he is having a point P. A point P. P which is 0, 0. Or should I write it externally? Okay. Why? Because I have to draw radius also. So you also, it's at origin. P equals to 0, 0. Now the second point, minus 2, 1. So here is a point Q which is having this minus 2 and 1. Now the third one, it is minus 3 and 2. Minus 3 and 2. So let's suppose it's here, minus 3 and 2. So these are the 3 points. This is given to us, guys. This is given to us. Now what we have to do? What we have to do? What is our input in this question? Our input is, we will construct something. We know we have to find a center and we have to find its radius. Any point on the circle. Any point on the circle is having the same distance from the center. So whether it's here or it's here or it's here or anywhere on the circle, the point is, the distance of the point from the center will be only equal to the radius. That means that will be the same. Okay, this is the property of circle. We all know this. Okay, now if I draw this line, this is Q and this is R, right? So if I draw this line, okay, so if I'll talk about this R and this O and I'll meet them, okay, now Q and O and I'll meet them, similarly P and O and I'll meet them. So these three will be the radius. Now radius is same. Now can I say that this RO is equals to this QO radius? Okay. Now this QO will be equals to PO radius. Now this is XY, this is XY and this is 0, 0. Now remember that distance formula when it used to be from the origin. The distance formula reduced to the distance formula, the great distance formula x2 minus x1 whole square plus y2 minus y1 whole square will reduce to only simply root of x square plus y square, isn't it? So this is great for us, guys, because it has reduced to a short form. So we will use this particular formula in this particular question. Okay, right. So given, what is given to us, guys? This is the point P which is origin 0, 0. This is Q which is minus 2 and 1 and the last one is minus 3, that is R. Okay, so R which is minus 3 and 2. These are the 3 points. Okay, so as OR, OQ and OP are radius, of circle, this is solution I am talking about, are radius of circle, which circle? Given circle. Then OR equals to OQ equals to OP, isn't it? And I can say that OR square equals to OQ square equals to OP square. Now, look carefully about O and P. Now, P is 0, 0. P is 0, 0, right? P is 0, 0. So OP square equals to OQ square. OP square equals to OQ square. This is first. Now, I will talk about the distance formula here. So, OP square will be what? X square plus Y square, simply because P has its ordinate and abscissa as 0, 0. So, it will be simply X square plus Y square equals to OQ square. Root eliminated with the square. Okay. Now, OQ square. O is having, I should write O here also. O is what? XY. So, O and Q. Q is 1. Q is here. So, that will be X minus minus 2. X minus minus 2 minus 2 minus minus and minus 2 is plus 2. So, X minus minus 2 whole square plus Y minus 1 whole square. This is first. That will be X square plus Y square equals to X square plus A square plus B square plus 2AB formula. Okay. So, X square plus 2 square 4 plus 2 multiplied by 2 multiplied by X 4X. Now, here again with the A square plus B square minus 2AB, we will open this. Okay. A square plus B square minus 2AB. So, now these will be cut, that will become 4x here minus 2y from there. Now, this is 4 and this is 1. So, 5 equals to 0. This is our second equation. Now, what will we take? Again, OP square, OQ square this time, so OR square this time, right. Now, OP square is again what? X square plus Y square. Okay. Now, OR, talking about OR. Now, O is there and R is there. So, again X minus minus 3, X minus minus 3, X plus 3 square plus Y minus 2 whole square. If I resolve this, that will be X square plus Y square as it is equals to A square, I am opening this bracket, A square plus B square plus 2AB. Here A square plus B square minus 2AB, right. So, again X square, Y square cut. Okay. So, that will be what, student? Equals to 0. What? Here 6x minus 4y and 4 here, 9 here, 13 equals to 0. Okay. Now, this was the third perception and this is the fourth equation we have got. Okay. So, now you are clear with that the center is O, which is having the coordinates as x and y. So, I am rubbing this. So, I am rubbing this particular diagram. Okay. Now, this is the first equation here and this is the second equation here. Now we can solve that. How can I solve this? If I'll go with that here and I'll write 6x minus 4y plus 13 equals to 0, can also be written as 6x equals to 4y minus 13 or x equals to 4y minus 13 by 6. Put this value of x in equation second. Okay, so 4. Now value of x is 4y minus 13 by 6, right? Then minus of 2y plus 5 equals to 0. From there I'll got 2 times, 3 times by the table of 2 times and 3 times. So 2 4s are 8y minus 26 minus 6y plus 15 equals to 3 will be go there, so 0. That will give you 8 minus 6y, 2y simply. Now minus of 15, minus of 26 and plus of 15. Okay, so that will be 1 here and that will be again 1 here. So 11, that implies that y equals to 11 by 2. If y equals to 11 by 2, put the value of x from here, x equals to 4 multiplied by 11 by 2 minus 13, right, by 6. That will be cut by 2. So 22 minus 13 by 6, that's equals to what? 22 minus 13, 9 here. Okay, so 9 by 6. Now 9 by 6 is what? 3 times 2 times. So 3 by 2. Okay, 3 by 2. So the value of x will be 3 by 2. So what you say, or coordinates of it, x equals to 3 by 2 and y equals to 11 by 2. Now these are what? The abscissa and the ordinate of the center. Okay, so note this. Now we'll talk about, so should I rub it till there? Okay, so till there I am going to rub it. So note that section particularly. Now you have to know the radius. Now this is center and pick any point. I'll be picking this. This is what? Any point. So by the distance formula, this is, you can pick this one also, but the simplest is this. So radius equals to OP equals to OQ equals to OR. So OP equals to x square plus y square root. Okay, and that will be, what is the value of x? 3 by 2 square plus 11 by 2 square, right. So from there you can calculate it. 3 threes are 9 by 4, 121 by 4. So now 121 plus 9, that will be 0 here, 3, so 130 by 4, right. So that will be by 2 if you, okay sorry, by 2 if you will cut that, that will be 6 and 5, 65 by 2. Okay, so can I write it 65 by 2? So that will be the distance, between the center and the other point. So that will be the radius. Okay, that will be the radius. So this is your question, student. Note it so that we can move forward. Okay, right, students. So this is about this question, and what else we are having? What else we are having? The bucket. Right. The next thing is section formula. Student, I am giving just an overview. We'll discuss it in the next lecture, but I am just giving you an overview of this, that what is section formula. We will be having a line. It's having two kinds, internally, externally. So we will having a line, right, which is AB. Now there can be a point, let's suppose P, that can be here. If it's here, that will divide it in two parts, and if I extend this, let it be here, that can be here also. In that case, it's also dividing it this and this part. So a point can divide or can have that segment of this particular line AB in two ways, externally and internally. So one by one we'll talk about this external thing and the internal thing, right? We'll talk about it, and we'll also find out the value of x and y in that condition. Value of x and y in that condition. Coordinates of P, right? Here x and y. So that will be the line, and that will be the axis, and we'll find out about this m ratio n. Okay, so we'll talk about it, but not in this lecture. In the next lecture, students, what you have to do, you have to practice questions based on the same thing, because I have provided you a variety of questions based on this distance formula. Now you have to practice it. Okay, you can search it, and you can find it in a sheet also. In the AriserTalent sheet, you can find it. Variety of question with the same variety and the different varieties. Okay, particular type of question, and the category is different. In some questions the category is same, but the numerical value is different. So you will be having both things, the variety of question and the practice things. Okay, so till then, practice and take care. Bye bye.